So seventh question, sine squared y plus cos xy equals to kappa. So like the way we did last time, we will have a separation for LHS and RHS, and we do the differentiation. So differentiate LHS with respect to x. So we get 2 sine y. We got this 2, so 2 sine y. Then we have to differentiate this sine y. So we get cos y. This is a chain rule. After that, differentiate y. So we get dy by dx. So this part is done. Then plus cos differentiation is minus sine xy. Then you have to differentiate xy. That means into bracket UV rule. So 1 into y plus x into dy by dx. So that's the second term differentiation. Right side, differentiate with respect to x, but that's equal to 0. So now we have to equate this to this. Okay, so we write this as a, so we write this entire thing as one entity. So you will get as dy by dx into 2 sine y cos y. So from here, this entire thing multiplies with this. So you will have minus x into sine xy. This is the dy by dx. So the next term is minus this y into sine xy. So that's equal to 0. So you take this to the other side. So you get dy by dx into 2 sine y cos y minus x sin x y equal to y sin xy. Understood, right? No questions, right? So then you get dy by dx equal to this entire thing. Okay, so dy by dx equal to y sin xy xy divided by whatever we have here, 2 sin y cos y minus x sin xy. 2 sin y cos y minus x sin xy, x sin xy. So this is the answer. Okay, any doubts or questions, or what you understood or what you haven't understood? No? So previous page, go here. Understood, right? So then I'll go to the 8th question. Okay, so I go to this question, I take this and I'll just say cut. Okay, so go to the next page and then I have paste. Okay, sine squared x plus cos squared y equal to 1. That's the 8th question. Sine squared x plus cos squared y equal to 1. This is not cos squared x. Okay, this is sine squared x plus cos squared y equal to 1. Obviously y has to be x in such a case, but we don't question all that stuff. We go ahead. Anyway, RHS differentiation is 0 because it's a constant. So LHS differentiation, 2 sin x and differentiating for sine, which is cos x plus 2 cos y. Differentiation of cos is minus sine y, and differentiation of y is dy by dx. So this entire thing equal to 0. So which means I can take this to the right side. So 2 sin x cos x equal to, this is minus, once it goes to the other side, you will have 2 sin y cos y dy by dx. So you can leave this 2 like that, we don't need to cancel it. So you get dy by dx equal to 2 sin x cos x divided by 2 sin y cos y. This is equal to, if you simplify, you will get sin 2x divided by sin 2y, because that's the formula, trigonometric formula. So that's the answer for 8th one. So now if you look at the 9th question, 9th question onwards you got the inverse trigonometry. As I told you other day, up to 8th you have one way of doing it. From the 9th onwards you will have a different method. Okay, so what is that method? I will tell you once I go to the next page. So before I start doing that, how do we do the differentiation of inverse trigonometric functions? So differentiating inverse trigonometric functions. So we'll start with y is equal to sine inverse x. How do we get dy by dx? So what we learned in inverse trigonometry was that you make sure that this inverse is gone. That means this is nothing but sine y equal to x. Remember doing this right in the inverse trigonometry. So now differentiate both sides. Differentiate both sides with respect to x. So left side you get cos y into dy by dx equal to, right side is 1. So dy by dx equal to 1 divided by cos y. That's equal to 1 by square root of 1 minus sine squared y. That's equal to 1 divided by square root of 1 minus sine y is equal to x. Therefore this is x square. So if you look at in this textbook, right, just above this exercise there is a table. He gives the table for what is the sine inverse differentiation, cos inverse differentiation, tan inverse differentiation, like that. Okay, so example, this is all given in the example how to do the inverse trigonometric differentiation. So we have dy by dx equal to this. Got it, right? So all the questions from 9th onwards, either you do in this way, that means you make sure that inverse is gone and then you do the differentiate, or you could do by substitution. Look at these things, right? You will be substituting something for this value x and then we solve that. Okay, so both ways we will do it. Now before we go to the 10th question, 10th onwards, I would just like you to check whether you can do a similar thing for cos inverse x. I would like you to do what is the differentiation for cos inverse x. You do it and you tell me the answer. You don't need to send to me, you tell me the answer. Okay, so y equal to cos inverse x. So just follow exactly the same thing. Okay, Correct. That's the first step. Yes. So you want to do, or you will be telling I'll write it. Cos y is equal to x. That's correct. What's the next step? Differentiate minus sin y. Okay. Equal to 1. Good. So dy by dx equal to 1 divided by minus sin y. Yeah. Okay. So that's equal to 1 divided by, or minus 1 divided by, we can take this minus to the top. Sin y means square root of 1 minus. Correct. Correct. 1 minus cos square y. Okay. Cos square y. So cos y is equal to x. Therefore the answer is minus 1 by square root of 1 minus x square. That's the answer. So you should be able to do for tan inverse also. Try. So we will go to the next page, or we will take it from here, this one. So we'll do it here. So y equals to tan inverse x. Tan y equal to x. So tan y differentiation is secant squared y into dy by dx equal to 1. Right? So dy by dx equal to 1 divided by secant squared y. So that's equal to 1 by 1 plus tan squared y. Understood, right? 1 by 1 plus tan squared y. So that's equal to tan y is equal to x. So you have 1 divided by 1 plus x squared. Yeah. So all these formulae, actually if you can memorize also, it will be good for all the inverse trigonometric. Okay. So you can do also, but then in exam, like if it is a 1 mark question, differentiate tan inverse x, or write the differentiation of tan inverse x. You can straight away write this. If they say differentiate, then you have to write all these steps. Understood, right? Two different way of questioning. If they say what is the differentiation of tan inverse x, you can straight give the answer 1 by 1 plus x square. But if they say differentiate, that means you have to show these steps. In both the cases, it's 1 mark only. So this is the reason. This is the reason in the exam, even in your tests, monthly tests or midterms or whatever, better not to attempt the 1 mark question in the beginning in the mathematics. 1 mark questions are to be answered at the end or the middle. Okay, definitely not in the beginning. Okay, important guideline. You can tell your friends also, because I have seen people wasting lot of time, and finally for big mark questions they don't have time. Right? So now we will go with the other question, which is our 10th question. So ninth question onwards. Sin inverse 2x by 1 plus x square. So you have a textbook in front of you. Then I'll suggest you to refer if there is any formula for sine inverse 2x by 1 plus x square, okay, in inverse trigonometry. So y equal to sine inverse 2x divided by 1 plus x square. If you say you don't have a formula, then we will do in a, are you referring? Can you refer to the inverse trigonometry chapter? And so there is a second, just before the last exercise, second exercise, you have that formula sine inverse x plus some properties, some 6 properties or 7 properties are there. Sine inverse x plus cos inverse x equal to pi by 2. Like that, you go to the next page. Just before the exercise, the last second exercise, you will see tan inverse x plus tan inverse y is equal to some formula tan inverse x plus y by 1 minus xy. All this formula we did that, right? You are able to find or no? No, inverse trigonometry. I think the second for we covered, remember, long ago, the inverse trigonometry chapter. That's the second chapter. The second there. So do you see anything that the sine inverse 2x by 1 plus x square is there on the right side at least? Any formula? Next page. Next page. Next page. Nothing is there. It's not there. Okay. Right. Then we will go with the method 1. There are two methods. Method 1 is we will be substituting something. Substitute x equal to something. Okay. I substitute x equal to tan theta here. Whenever we do the substitution, do the differentiation here like a chain rule. Remember that dx by d theta equal to secant square theta. Secant square theta is 1 plus tan square theta. So dx by d theta equal to tan theta is x. So I have 1 plus x square. Alright. So we just try to do what is the substitution, how much we get the substitution. So this is basically a substitution. Now we rewrite this y with that substitution. Y is equal to sine inverse 2 tan theta divided by 1 plus tan square theta. So this is equal to sine inverse, this entire thing is written as sine 2 theta. This is that formula which we learnt in that inverse trigonometry chapter. Therefore y is equal to sine inverse sine, so you have 2 theta. So to get dy by dx, it's actually not x, it is theta. So we do first dy by d theta multiplied by d theta by dx. This is the chain rule. So dy by d theta, that means you are differentiating this. Just 2 is the answer. D theta by dx, we have dx by d theta. So that will be 1 by 1 plus x square. So the answer is 2 divided by 1 plus x square. This is the method 1. So method 2, of course method 2 sometimes it will be too difficult, that means it will be lengthier, so we don't recommend to use method 2, we recommend to use the method 1. Okay, method 2 is y is equal to sine inverse 2x divided by 1 plus x square. So this becomes sine y, the way we have done the sine inverse x cos inverse x, 2x divided by 1 plus x square. Then differentiate both sides. So you will get cos y into dy by dx equal to, this is u by v rule, quotient rule. So you will have 1 plus x square whole squared. Then differentiation of the u, you get 2 into 1 plus x square minus 2x differentiation of denominator, you get 2x. So you get cos y dy by dx equal to 2 plus 2x square minus 4x square divided by 1 plus x square whole square. Any questions? Understood, right? Okay. Yeah. Now you are making this as a subject, dy by dx as a subject. So you will get dy by dx equal to, here the 2x square is gone. So you will have 2 minus 2x square divided by 1 plus x squared whole square. That's equal to 2 you take off common, 1 minus x square divided by 1 plus x square whole square. Now there is a small thing we have to do. When we have sin y is equal to 2x by 1 plus x square, we have to draw a triangle to represent this. So for example, we are drawing a right angle triangle. So we draw a right angle triangle and then we'll write this is equal to y. Sin y means opposite side, which we'll take it as 2x, divided by hypotenuse, we'll take this as 1 plus x squared. So using Pythagoras, when we solve it, you will get this as 1 minus x squared. So cos y is nothing but 1 minus x squared by 1 plus x squared. So based on this, we will write now dy by dx, sorry, here we have cos y also, right? Cos y into dy by dx. So cos y into dy by dx equal to, this left side, the right side will be 2 divided by cos, not divided by. So you'll have 2 1 minus x square divided by 1 plus x square into 1 by 1 plus x square. I have split this whole square into 2. Okay. So you see now 1 minus x square by 1 plus x square is nothing but this entire thing is cos y. So this cos y get cancelled. So dy by dx equal to 2 divided by 1 plus x square is the same as this. Okay, same answer. So this is a easier one because you got only simpler thing here. Next question, for example, 10th question, we cannot do with the second one, method 2. It will be tougher one. Okay.